Here we go. I am Mr. Bishop back with you here, the guy with the apple and an arrow on his head and the Bitmoji right here. Today we're talking about multiplying two matrices together. This is chapter 2, day 2. So in the last video we talked about how to add and subtract matrices, and we also talked about scalar multiplication, which was essentially just multiplying a constant term through the entire matrix, sort of like distribution. Well, in this case, we want to know what's it look like when you multiply one matrix times another matrix. What might that look like? Okay, I need this room to write here, so I'm going to erase this really quickly. The first question is, when is it legal to multiply two matrices together? So how do I know when it's okay to multiply matrices together? Sometimes it won't be okay. Sometimes the math police, of course, will take issue with what you're trying to do. But when is it okay? When do I actually multiply two matrices together? Well, it comes down to their dimensions. So we have to start by checking the dimensions of our two matrices. And we know dimensions are just rows times columns. So let's say we have our first matrix here, whatever it is, however many entries are in it. And then our second matrix here, we're trying to multiply this matrix times this matrix. We have to consider their dimensions. So we know the first matrix will have rows times columns. The second matrix will have some rows times columns. Well, here's the deal. Right away we can read between these two dimensions and tell if it's going to be okay to multiply these matrices together. So we start by looking at these inside numbers, right? So you notice we're comparing the dimensions here, side by side. We compare these inside numbers. So it'd be sort of like the number of columns for this matrix compared to the number of rows for this matrix. And if those numbers match, you've got a winner, right? You just struck it rich. You won the lottery in this case. The inside numbers, if they match, then it's okay to move forward. We can actually multiply these matrices together. And then, so let's say they match. We're going to multiply these matrices together. What will our new matrix look like? In terms of how big will it be? What will the dimensions of the new matrix be? Well, that's actually easy enough to tell also. We just have to look at the outside numbers, right? When we're comparing these two matrices, look at the outside numbers, and those will tell you the dimensions of your new matrix, sort of like the offspring from the parents. The outside numbers are going to tell you the dimensions of your new matrix. So let's consider a problem from the Day 2 worksheet. Number 27 on the Day 2 worksheet, for example. They tell you, you have a matrix, call it matrix A, capital A, and it's a 3 by 4 matrix. You don't need to know about all the specific entries. Just know that it's a matrix that's 3 by 4. It's got 3 rows by 4 columns. And then you've got another matrix, call it matrix B, that is a 4 by 5 matrix. Right? Without knowing all the entries, you don't need to know that. You just need to know at this point the dimensions. So the directions for this question essentially ask you, is it okay to multiply matrix A times matrix B? And if it is, what would the dimensions of the new matrix be? Okay, so we have the dimensions of matrix A here compared to the dimensions of matrix B. The first thing we have to look at is those inside numbers. So the number of rows on matrix A compared to the number of columns on matrix A compared to the number of rows on matrix B. I'm going to color code it again. There we go. So those inside numbers, by comparison, we got a winner, right? Those numbers match. So yes, we can move forward, and if we wanted to multiply these together, we could. So that's our first indicator when we're trying to multiply two matrices together, which in this case, we're not actually going to multiply anything. We just want to know if it would be okay. And since it is okay in this case, how big would the resulting matrix be? What would the dimensions be for that matrix? Well, again, I'm going to color code in purple here. The dimensions of our new matrix, if we multiplied matrix A times matrix B, we look at the outside numbers while we're comparing the dimensions. So that would be 3 by 5. So the dimensions of our new matrix, the offspring of matrix A and B, the child, if you will, would be a matrix that's got 3 rows by 5 columns. So we're not actually multiplying matrices together yet. We just want to know, is it okay to multiply matrices? And then if so, what will the dimensions of the resulting matrix be? Let's take a look at number 29 from the worksheet. Number 29 says, what if matrix A is a matrix that's got 3 rows by 2 columns? Whatever's in there, we don't know. Doesn't matter at this point. And what if you got another matrix, matrix B, that's 3 rows by 2 columns? So the same dimensions. So if I wanted to multiply matrix A times matrix B, is that possible? First question you have to ask yourself, compare the inside numbers here now that we've got the dimensions. So we've got a 2 and a 3 as our inside numbers. Number of columns on matrix A is 2, number of rows up. So right away, you notice I put it in red here. That's a no-go. So our inside numbers don't match. We're done. We cannot multiply these two matrices together. So right away, if they don't match, can't do it. Okay, so now we know when it's okay to multiply them together and how big the resulting matrix will be once you've multiplied those matrices together. How do you actually multiply these things then? So to multiply two matrices together, I'm going to summarize it in simple terms, then we'll go through it and see what it actually looks like. You're essentially going to multiply each row from the first matrix times the corresponding column in the second matrix. So row 1 from over here would get multiplied by column 1 over here. Then you're just going to add up the results for each of those entry products. Well, what does that mean? Let's take a look. I have an example here. I'm going to give you a matrix. It's a simple one. It's a row matrix, right? It's got 1 row and then 3 columns. Times a column matrix here. It's got 1 column and 3 rows technically. So right away, we've got a 1 by 3 and a 3 by 1. And the reason I point out the dimensions, you have to ask yourself that in the very beginning. Is it okay to multiply these together? Well, now we can compare the dimensions. We've got a winner. The inside numbers match. And so we know it's okay to multiply these together, and we know the dimensions of our new matrix, the offspring, if you will simply be a 1 by 1, because that's the outside numbers here. So our new matrix is going to be a 1 by 1. So let's see if we can follow the instructions here to multiply these together. We're going to multiply each row by the corresponding column. Well, that's simple. There's only 1 row from this matrix and only 1 column here. And then once we multiply each corresponding entry, you just add up the results. So let's see. 1 would get multiplied to the 0. So 1 times 0, I can even handle that math. Plus, the next terms would be negative 2 would get multiplied by the 1. Right? So the second term in this row multiplied by the second term in this column. Plus, finally we have the 3 would get multiplied by the 2. And voila, we sum these up, we have our final answer to put in a 1 by 1 matrix. So let's see. That's 0, negative 2, and 6 for a grand total of 4. And there's our 1 by 1 matrix. Okay, not so bad. We're easing our way into this. That was just a row matrix times a column matrix. Let's do one more example here in this video. What if I have a 2 by 2 matrix like this times a 2 by 1 matrix, this column matrix right here. So does that work? Am I able to multiply those together? Let's compare 2 by 2 for this, and then for the other dimensions we have a 2 by 1. Right away, look at the inside numbers, we've got a winner, we've got a match. So we can move forward with multiplying these. And our new matrix is going to have dimensions, look at the outside numbers, 2 by 1. So the new matrix is going to be a 2 by 1. That means 2 rows by 1 column, essentially sort of the same setup as that guy right there, right? Our column matrix. So I'm going to go ahead and put my little blank matrix down. I'm just going to put a blank here, right, and do a little bit of math. I know it's going to be 2 rows in 1 column. Okay, and we're supposed to multiply each row in the first matrix by the corresponding column over here. So there's only 1 column to multiply by. That makes things easy. Let's do row 1 times our first column there. So let's see. I'm going to try to color code this a little bit. Row 1 times our column 2, 4 there. So the 2 is going to get multiplied by the 2. Row 1 times column 1. 2 multiplied by the 2. Look at that, I'm color coding. Plus, well, the 0 has to get multiplied by the 4. Excellent. There you go. You multiplied this row by the only column there is over here. Do a little bit of math. That gets your first entry. How about down here? Seems like we still have another row to take care of, right? So I'm going to color code this one in green. Let's do the second row times our column. So in green, I want to do that row times the only column over here. So the 4 is going to get multiplied by the 2 there. Plus, we got to take care of the negative 2. That's going to get multiplied by the 4 over here. Okay. Now let's just simplify these terms. Let's see. We've got 4 plus 0 up here. That's easy enough. And on the bottom here, we've got 8 plus negative 8. So our final answer for our 2 by 1 matrix is 4 for the first entry and 0 for the second entry. There you have it. Now we are really rolling with multiplying matrices together. Okay, to summarize, we talked about when you can actually multiply 2 matrices together, right? The inside numbers have to match. And if you can actually multiply them together, you get the green light. You know the offspring, the new matrix from that product, will be the size of, well, whatever the outside numbers are, right? The outside numbers will tell you the dimensions of the new matrix. And then we talked about the steps for actually multiplying them together, right? Multiply each row times the corresponding column. Then you add up the results, right, for each of those entries to get your new matrix entries. All right, that's all for now. Thanks for watching.